Alright, so in this video, we're going to do questions related to the transformations of trigonometric functions. And here's something that you need to know. Suppose we have something like a sine bx minus phi plus c, or a cos bx minus phi plus c. So here's what you need to know. If you have, usually we're going to work with sine and cosine for questions related to this, but here is the information that you need to know. C, so y is equal to c is your line call, or is your principal axis. So what is the principal axis? The principal axis is the line, the horizontal line passing through the midway of the maximum and the minimum of the graph. So if you just remember the graph of, let's say, sine x, right? Let me just bring it here. So your maximum is 1. Your minimum is -1. So the line passing through the midway of 1 and -1 is this line when y is equal to 0. So that is your principal axis. All right. So y is equal to c when your graph is in this form, because this is just sine x, right? Instead of theta, I said x. So we have plus 0. So y0 is equal to 0 is your principal axis, because c is 0. All right, so that is the one thing, the first thing that you needed to know. The second thing is that phi is the phase shift, i.e., a horizontal translation by the vector phi 0, right? It is a horizontal translation, but we also call it the phase shift. All right. Part 3, modulus A is the amplitude. So basically, if you have like -3 here, you just want to take the modulus. That means the positive value of it. -A is the amplitude. What is the amplitude? Well, it's the distance between the principal axes. What is the amplitude? It is the distance, or we can also say the maximum displacement from the principal axis. So if you look at here, this is your principal axis. What is the maximum displacement? It's 1 unit. So that is the amplitude. The amplitude is 1. So you can also measure it here, right? This is still 1 unit. So you can, the distance between the principal axis to either the maximum point or the minimum point, that is your amplitude. So in this case, 1 unit, that is your amplitude, right? 1 is your amplitude. All right. And then finally, 2 pi over b, which is in radians, or 360 degrees divided by b in degrees, is the period. All right, so that is all that you need to know. These 4 very, very important facts. All right. So if you have tan, it's the same logic, but instead of 2 pi over b, it's pi over b, or 180 degrees over b. So that is the period for tan bx, right? So if you have this, why? Because the period of tan is pi, right? For sine and cosine, it's 2 pi. So that is the difference. So if you have tan bx, then the period is pi over b, or 180 degree over b. So whatever you want to find it in. If you want to find it in degrees, it's this. If you want to find it in radians, it's this. All right, so let's do some questions. I hope this information was helpful. So we're going to do some questions here. Write down the period of each of these functions. So for cosine of x, it says in degrees. So it's 2 pi, which is 360 degrees, right? So that is your solution. It's 360 degrees because they want the answer to be in degrees. Sine of 2x. Remember, b is equal to 2 here. bx, right? bx. So it's 360 degrees divided by 2. And that gives you 180 degrees. That is your period. All right. For C, it's tan. So tan, you start with 180 degrees divided by b, right? 1 over 2. And that gives you 360 degrees. All right. So for the period, you just look at the factor multiplying x. Sine x usually has a period of 360 degrees, and then you need to divide by b. So that is just 120 degrees, right? All right. Tan x is just 180 degrees. Nothing it's only 1 that multiplies x, so it's just 180 degrees. And cosine, so you just need to look at what is multiplying. bx, this is the phase shift. This is the amplitude. So you just need to look at this, right? So period in degrees is 360 degrees divided by 2. That is 180 degrees. And we are done with question 1. Question 2, write down the amplitude of each of these functions. All right, amplitude is the number here, the positive, the modulus of the number in front multiplying the trig function. So the amplitude is just 1 here. All right, it's the modulus of the number in front. So the amplitude is just 5. Modulus of the number in front, the amplitude is just 7. All right, so you should write this as negative 3 cos 4x plus 2, right? And this, remember, is your principal axis. It's your vertical shift. So what is your amplitude? It's the modulus of this number. So that is just 3. So always the positive value, because it's the maximum distance. Actually, displacement also works, but maximum distance. So always give your answer positive. So this is directly 4. This is directly 2. All right, so we are done with question 2 as well. So question 3, I'm going to come back to this towards the end because it's graph curve sketching essentially. So I hope I can erase my answers here. So I'm going to come back for 3. 4 is also curve sketching, but it's a bit easier because there's only 3 questions. All right, so I'm going to do 4 first. So firstly, step 1 is draw a rough sketch of your main function. So secant x, cot x, and cosecant x. Draw these first, a rough sketch within this interval, right? So what does secant x look like? Well, I know that secant x is not defined for odd multiples, is not defined, right? Secant x is not defined for odd multiples of pi by 2. So this is pi by 2. This right here is going to be 3 pi by 2. And then in middle, you're going to have pi here, and you're going to have 2 pi here. So secant x, this is 1, looks something like this. And this is, let's see, negative 1 is here. So it looks something like this. For the domain that they're asking for, looks like this, right? So now, it looks something like this. All right. So now you need to draw plus 1. Plus 1 means you need to shift up by 1 unit. And if you do that, then from 1, you go up to 2. From negative 1, you go up to 0, right? Negative 1 plus 1 is 0. So your curve looks something like this, as drawn in the green part. So if you add 2, you get something like this. And it basically, if you add, you're adding 1, right? So your maximum value, instead of being 1, it's going to be 2. So it's going to look something like this. So just make sure you draw a horizontal line here to show that it can't be less than 2. All right. Something like this. So So that is how your curve. So I did not do 3. I skipped 3 for a while. But yeah, that is what your graph is going to look like. A very rough sketch. So I hope this was clear. All right. So the graph is in green, by the way. In green, not pink. Pink was the sketch of secant x. So it's going to look something like the one in green. And you can erase your lines afterwards so that you are more clear. All right. So let's erase this. Now let me draw. We're done with 4 part 1. Okay, I forgot. We need to describe the asymptotes, right? So we have vertical asymptotes. You just want to say you have vertical asymptotes at pi by 2 and 3 pi by 2. That's it. Just say that you have vertical asymptotes at x is equal to pi by 2 and x is equal to 3 pi by 2, because we're only plotting from 0 to 2 pi. All right. So now, let's plot the graph of cot x first. The graph of cot x. So cot x, if you remember, it's not defined for value. It's not defined for multiples of. It's not defined for n pi, right? X is equal to n pi. So at pi and 2 pi, it's not defined. At 0, it's not defined. It's not defined for pi. It's not defined for 2 pi. So you have, this is 3 pi by 2. This is pi by 2. All right. So your graph looks something like this. Right? In pink. The graph in pink is your graph of cot x. All right. But we don't want cot x. We want cot 2x. So what does that mean? Well, you keep your y coordinates the same, invariant y-axis, if you remember from chapter 4. But your x values are stretched by a factor 1 over 2, right? 1 over b, that is your horizontal stretch factor. So you just want to multiply all your x coordinates by 1 over 2. So let me draw it, actual graph on the side, right? So previously, you had an asymptote at pi, but now you need to multiply pi by 1 by 2. So your new asymptote is at pi by 2. So your new asymptote, if this is pi by 2, if this is pi, let's say this is 3 pi by 2, and this is 2 pi, your new asymptote is at pi by 2. All right. And you also had an asymptote at 0. So 0 times half is also at 0. So you also have an asymptote here. You also have an asymptote here. All right. So you had a 0 point at pi by 2. So that is going to be now at pi by 2 times 1 by 2. That is pi by 4. So your 0 point actually is somewhere here. So your graph now looks something like this. It's basically stretched, more squished together. Right? So, okay, let me increase the gap so that my diagram is a bit more clear. All right, so let's say this is, okay, let's say this is pi by 2, pi, 3 pi by 2, and 2 pi. All right, pi by 2, pi, 3 pi by 2, and 2 pi. All right, so our asymptotes was at 0 and pi by 2. So this was our new asymptote, right? And our 0 point shifted to pi by 4. So our graph looks something like this. So on the same axes, if you draw them, you're going to see that it gets squished together. All right. Another asymptote was at 2 pi. So 2 pi times half. So our new asymptote is at pi. So we also have an asymptote at pi. All right. So our graph, and we had 0 at 3 pi by 2. So that is, if you multiply by half, you are going to get a 0 at 3 pi by 4. So 3 pi by 4 is somewhere here. So you get something like this. And basically, if you think about it, your period is from this, because cot and tan and cot both have a period of pi. So 2 times pi, your period changes to pi by 2. So your graph repeats for every pi by 2, and you can see that here. This until pi by 2, for another pi by 2, because the difference between pi and pi by 2 here is also pi by 2, right? So you have that. So for here as well, and you're going to have something like this. Goes to 0 and goes down. It comes down, goes to 0 and goes down. So your graph looks something like this. So you're going to have 4 branches. You're going to have 4 branches. And if you check the back answer, you're going to have 4 branches. All right. So I hope that makes sense. You're going to have 4 branches. And where are your, for part B, where are your vertical asymptotes going to be? You have x is equal to 0, x is equal to pi by 2, x is equal to pi, x is equal to 3 pi by 2, and x is equal to 2 pi. So this is where your vertical asymptotes are. This is where your asymptotes are. All right. Okay, we're done with B, and let's do C. No, part 3. So I hope 1 and 2 were clear, and we described the asymptotes. So let's draw cosecant x first for this range, right? So what does cosecant x look like? Well, cosecant x look like this. If you remember, it was like this and like this, right? So this is 2 pi, this is pi, this is pi by 2, this is 0, this is, sorry, this is 3 pi by 2, this is pi. So this is what it looked like. This was the graph of cosecant x. But now we need to shift it by pi by 2. So this is a horizontal, if you remember from chapter 4, this is a horizontal translation by pi by 2, 0, right? By this vector. All right. So now, let me draw it on another axis. But now let's shift our asymptotes first. So we're shifting in which direction? We're shifting to the right, right? Because we're shifting by positive units. So we had an asymptote at pi. Now it's going to shift by pi by 2. It's going to be at 3 pi by 2. All right. So let me draw pi by 2, pi, 3 pi by 2, and 2 pi again. But now our asymptote has shifted from pi to 3 pi by 2. And if you look at the gap between your asymptotes, right? So 3 pi, this asymptote was not there before, but you had an asymptote for every pi distance. You had an asymptote at pi, you had an asymptote at 0. So this distance is pi, and this distance is pi. So you want to keep that. So your asymptote is also going to be at pi by 2, so that this distance is pi. All right. And now, this whole curve shifts in this way, right? So at pi by 2, you had positive 1. But now it's going to shift here at pi. So your graph looks something like this now. It's shifted by pi by 2. And here, if you shift this, right? This point goes here at 2 pi. From 3 pi by 2, it gets shifted to 2 pi. So you have negative 1. Your negative 1 point gets shifted to 2 pi. So you have that arm looks something like this. All right. And you also have an arm that will look something like this here. And, well, where do we get this from? Remember, your graph also exists on this side. So you also had this here. And because we're asked to plot from 0 to 2 pi, when you shift this, this part is going to get to here. And it's going to exist between 0 to 2 pi for this new curve, right? So you have to draw it here as well. So it's going to look something like this. So I hope that explanation made sense. But yeah, this is what your graph looks like. So this is 1. This is positive 1, by the way. All right. And yeah, you have asymptotes at pi by 2 and 3 pi by 2. All right. That was not easy, but I hope it made sense. You're just using concepts that you learned in chapter 4, essentially. All right. So this is the graph. This is your rough sketch and how you translate it. All right. So part 5. So these are sketches. Sketches means very rough diagrams. On the same diagram, sketch the graphs of sine 2x and okay, rather than doing these questions first, I'm gonna do question 9, question 8 and question 9, and we're gonna get back to the drawing questions. All right, so part of the graph, so this is exactly the format I gave you, right? Find the value of a, b and c. All right, this is quite straightforward. C is your principal axis. What is your principal axis? C is your principal axis. Principal axis is the line passing midway between maximum and minimum values. So what you do, you take your maximum point, 9, you take your minimum point, 1, and you take the average. So that gives you 5. So if you draw a line from 5, and if you think about it, what is the distance to the maximum point? Well, that distance is 4. And what is the distance to the minimum point? That distance is also 4. So this line passes midway. So C is just 5. Very straightforward, right? All right. What is A? A is the amplitude. And what is the amplitude? We just said that the maximum distance from this axis to the highest point is 4. So A is just straightforward 4. All right. So what is B? Well, the period is 2 pi because we have in radians over B, right? So what is the period of the graph? Well, let's see. It repeats one cycle in pi, another cycle in pi. So the period, by looking at the graph is repeating for every pi, right? One cycle is finished in pi. One cycle is finished in, from pi to 2 pi is also finished in pi, right? So your period, if you use this, you are going to solve for b. So 2 pi over b is equal to pi. Pi and pi cancel out. And if you solve for b, you're going to get b is equal to 2. So you're done. A is 4, C is 5, B is 2. So that is the solution to question 8. A is 4, B is 2, C is 5. All right, we're done. Question 9. So let me erase this. I hope that is okay. Question 9 is exactly the same question, right? So now we're working with degrees. That is just it. So A, just rewrite the equation in a way you're familiar with. B cos cx plus A. And A is going to be the line of your principal axis. So A is just take the maximum value, principal axis, plus take your minimum value divided by 2. So that is 6 divided by 2 is just 3. So A is 3. Very straightforward. Now draw a horizontal line at 3. What is the distance, maximum distance? That is 3 to 5. That is just 2, right? So that is going to be your amplitude. And what is your amplitude? It is B in this equation. So B is just 2. All right, A3, B2. And now we need to find CX. CX is related to the period. So 360 degrees divided by C is the period. And let's look at the graph to figure out what the period is. So it starts at it starts at 5. One cycle, it should reach 5 again. So one cycle, it goes down, comes up, reaches 5 again. So that is one cycle. And one cycle, to get to one cycle, it takes from 0 to 120. So your period is just 120 degrees. And if you solve for C, you are going to get C is equal to 3. And that is it. A3, B2, C3. And we are done with question 9. All right. Now let's think about. Okay, this is question 10 is fairly simple. It says sketch the graph of 2 sine x. The period is just 2 pi, is just the period of regular sine x. There is no translation, be it horizontal or vertical, because nothing subtracts or adds x and there is no value plus c here. So only difference is that amplitude is equal to 2. So we can draw it, right? And it says we are given the domain from negative pi to pi. All right, so let's say negative pi is here, negative pi by 2 is here, this is 0, this is pi by 2, and this is pi. All right, so we are asked to draw the graph of 2 sine x. So it's going to go up to 2 and negative 2. So your graph looks something like this. Sorry, not the best diagram, something like... Okay, my diagram is so bad, but bear with me. Something like this. So the only difference between the sine x graph and this is that this graph has an amplitude of 2. So your maximum value is going to go up till 2 and negative 2. All right, so this is how your graph is going to look like. The straight line kx, y is equal to kx, intersects this curve at the maximum point. So a straight line intersects here. So this line intersects here. Y is equal to kx. So what is... Find the value of k, give your answer in terms of pi. All right. Sorry. It's not a horizontal line, it's a straight line. Okay, my bad. But, okay, y is equal to kx. Remember, there is no plus c. So what is y-intercept? It's 0. So it passes through the origin. And it looks something like this. So it should pass through the minimum point as well, technically, I think. Something like this, right? So what is the slope? Basically, you can find this by using the slope, right? Because this is going to be the slope of the straight line. So k is just the slope, right? It's delta y over delta x. So what is the slope? Well, change in y from this point to this point is 2. And the change in x is from 0 to pi by 2. So your solution is 4 over pi. That is the k value for question 10. Is 4 over pi. All right. So we're done with A, we're done with B. State the coordinates of the other points where the line intersects the curve. So the line intersects the curve at this point as well, I think. Yeah, it does. So the other point where the line intersects the curve is negative pi by 2 and negative 2. And 0, 0, right? Definitely 0, 0, because it intersects the curve at the origin, at this point, and at this point. And basically, if you just draw your graph accurately, this should be very obvious to figure out. Because if it goes pi by 2 units here, and if it has to go up by 2 units, then if you go negative pi by 2, you have to go down by 2 units, right? That is just how you draw graphs, straight line graph. So your straight line passes through the maximum point and the minimum point, something like this. So that is why negative pi by 2 and negative 2 is a point of intersection, and 0, 0 is a point of intersection. All right, so we're done with question 10. Question 11. Part of the graph is shown above, right? All right, so remember, tan bx. So we know that period for tan is pi over b. Pi over b, not 2 pi, but pi over b. And we are using pi because our graph is given in radians, right? And let's just use this graph to figure out our period. So the period for tan is, what is the repeating unit? This is your repeating unit for tan, right? If you remember, this is your repeating unit. So it goes from pi by 2 to 3 pi by 2. And what is this distance? So it's repeating for every pi units, right? So it's just pi. So b is just, you're going to find out, it's just 1. All right. So b is 1. C is the principal axis, right? So the principal axis for tan of x, so the principal axis for tan of x is equal to, you can say is y is equal to 0. Or another idea is that if you draw your regular tan x graph, something like this, then this point, you have a curve point at 0, 0, right? But now this point has been translated up. It is now at 0, 5. So that is a vertical translation by 5 units. So plus c, this has to be plus 5. So you can immediately deduce C is equal to 5. All right. For question 11, B1, C5. All right. So what is A? How do you figure out A? Well, you just substitute this point. 8, right? That is the y coordinate, is A tan. We know B is 1, so you don't have to worry about that. X is pi over 4 plus 5. And what is tan pi over 4? That is just 1. All right, so 8 is equal to A plus 5, and A is just going to be 3. A3, C5, B1 is your solution. A3, B1, C5, yes. All right, we're done with question 11. Okay. So I hope I can erase this. Question 12. F of x is a plus b sine of x. All right. So f of x is equal to a plus b sine x. That is given. And for this domain, let's not worry about that. Given f of 0 is 3, just substitute 0 here. A plus b sine 0, and that is equal to 3. Sine of 0 is 0, so you immediately figure out a is equal to 3. A plus 0 is 3, that means a is equal to 3. All right. And f of 7 pi over 6. F of 7 pi over 6 is equal to 2, right? So you can substitute 3 here already. 3 plus b sine, I don't know what b is, but if I put 7 pi over 6, my output is 2, right? So b times sine 7 pi over 6 must be equal to -1 if I subtract 3 on both sides. What is sine 7 pi over 6? Well, what is 7 pi over 6? If you convert this to degrees, that is 210 degrees. So now we can solve for this, because 210 is just 180 plus 30 degrees. And we know how to solve this from the previous video. Well, sine 180 plus 30 is just keep sine as it is, 30 degrees. This is in the third quadrant, so you put a negative sign because sine is negative there. So and these negative values cancel out. B sine 30 is half is equal to 1, so B is equal to 2, right? Because you multiply by 2 on both sides, and these 2 cancel out, and you get B is equal to 2. All right, so that is the solution to 12a. B is equal to 2, A is equal to 3. A3, B2. All right, find the range of f. So how do you find the range? All right, remember, sine of x is always between -1 and +1, right? So now, first let's multiply by bx. What is b? It's 2, right? So if you multiply by 2 sine x for inequalities, you know that because we're multiplying by a positive value, the direction of the inequality does not change. So 2 sine x will be between -2 and +2. Now what we need to add? We need to add a. And we know that we can add any number to an inequality without changing the direction. So what is a? A is equal to 3. So add 3 to both sides. So -2 plus 3, 2 sine x plus 3 is 2 plus 3. And from this expression, you get that 2 sine x plus 3 is less than or equal to 5. And this is actually your range, because this is your f of x. And your f of x is between 1 and 5. So that is the range. And sine of x is a continuous graph, so you don't have to worry. So this, you can also write it as 1 f of x less than or equal to 5. So this is your range. So I hope that was clear. And it's quite easy to figure it out. So that is the solution to 12. All right, I hope I can erase stuff. All right. Okay. So we're done with 12 and 11. And we are done with 10, 9, and 8. We are also done with 1, 2, and 4. All right. So good amount of progress. Question 13. This is very similar, right? Maximum value of f of x is 8 and the minimum value is -2. What is a? Is the principal axis. So we know how to find the principal axis. You take your maximum value, you add your minimum value, and you divide by 2. So that is just 3. So a, immediately you figure out, is 3. And now, to get from 3, right? So your principal axis is here. Your maximum value is 8. So what is this distance? This distance is 5, right? between 8 and 3, your distance is 5. So that is the amplitude. And your amplitude is just b. So b is just equal to 5. Right? Because given a and b are positive constants, so b is 5, that is directly the amplitude, and a is 3. All right. So now you just want to sketch the graph of f of x. So how do you do that? All right. So the way that you do that, we're done with a. So instead of, I'm going to erase everything. So a3b5, and I'm going to write it as f of x is equal to negative 5 cos x plus 3, right? Because b was negative 5, we had minus b and b is positive, so b is 5 and a is 3. I just rewrite it like that. All right, so let me draw the regular graph of cos x between what values? So we are given a domain, so between these values, right? So between that value, the graph of cos x looks something like this. Goes from 1 to negative 1. Pi by 2 is 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? So it looks something like this. That is what the graph of cos x looks like. But now you're multiplying by negative 5. So if you multiply this output, right, it's a vertical stretch, right? So you have to multiply your output here by negative 5. So your output is going to go down to negative 5. From positive 1, it's going to, if you multiply by negative 5, so it's going to come down here. So I'm just switching my values because I'm going to draw the graph at once. At 0 times negative 5 comes at 0. 180, it was negative 1. So negative 1 times negative 5 is going to go up to positive 5. Right? And then 0, 0, it's going to come down to negative 5. So the pink curve is what happens after you do the vertical stretch. Now you need to do the vertical translation. So you need to add plus 3 to all values. So negative 5 plus 3 comes up to negative 2. 5 plus 3 goes up to 8. So your graph, sorry, no, not like this. Your graph, okay, at 90, 0 plus 3 goes up to 3, right? So your graph looks something like this. So like the orange curve. So this is going to be 3. This is going to be 3. All right. So you just do the vertical stretch first. You multiply your output by negative 5. You draw your graph. And then you shift it up by 3. So it looks like something like the purple curve. So your minimum point is at negative 2. It's given here. Your maximum is at 8. So it satisfied the description, the orange curve. So your orange curve is your solution. All right, so that is the rough sketch. I hope that made sense. All right. All right, question 14 just asks us to find A, B, and C. No sketching, so that's quite straightforward. A is your principal axis, right? Think about the first thing I gave you in this video. All right, so C helps you find your period. So because we're given in degrees, 360 degrees divided by C is your period, which is 120 given here. So you can immediately solve for C. It's going to be 360 divided by 120, which is just 3. So yeah, we're done with C. B is the amplitude. We can figure that out. But first we can figure out A. The maximum value is 9. The minimum value is 1. And you take the average. So that is just 5. And if your midpoint is at 5 and your maximum value is 9, what is the distance? That is just 4. So your amplitude, which is B, that is just 4. And we're done. So that is A5, B4, and C3. All right, pretty much it. So we're done with question 13, 14. And the last question for this video is going to be question 15. And probably everything else that I leave out, I'm going to do it in the next video. All right. So the maximum value of f of x is 7. Okay. And we know the amplitude. It's 5. All right. So you can figure out a, right? If your maximum value is 7 and your midpoint is at 5, sorry, if your amplitude is 5, then that is the maximum distance from this midway line to your maximum point, right? 5 should be the distance between 7 and your midway line. So basically 7 minus 5 gives me this line, which is 2. So A is just 2. And what is the value of B? Well, period is 60. So 360 degrees divided by B, right? Because cosine has a period 360 or 2 pi, should give me the period, which is 60 degrees. So if you solve for B, you are going to get 6. So A2 and B6. That is your answer. What is the amplitude? Well, directly you get it from the equation. It's 5. Sketch the graph. All right. So just... Okay, that is not easy. All right. So... Okay, I don't want to be lazy, so I'm going to do it. Ooh. It's going to be an ugly graph. That is the issue. The graph is ugly. All right. So you can draw the graph of cos x and perform the translation, or you can also draw based on the description that you have, right? Wait, okay, let me draw it because it asks us to draw between these values, right? So let's do our partition by 30 degrees. 60 degrees, 90 degrees, and 120 degrees. All right. So A is our principal axis. Principal axis A is 2, right? So at 2, let's say this point is 2, I'm going to draw my principal axis. So this horizontal line is my principal axis. My amplitude is 5, right? So put 0 here. Cos 0 is 1, right? B times 0 is 0. So this is 1. So 5 times 1 is 5 plus A2. So at 0, we are at our maximum point 7. All right. So that is a good thing to know. And our period is 60 degrees. So it finishes cosine. That is one period. That is what happens in one period, cosine. So it finishes by 60. So we start at 7. Our minimum point is going to be 2 minus the amplitude, right? So negative 3. So our minimum point is going to be at negative 3. So how do I know that? Well, the distance between 2 and 7 is 5. So 2 minus 5, I get to negative 3. All right, so if I draw the graph, at 60, I have to be back up here. And I have to finish my whole cycle. So what happens if I put 30 inside? 30 is pi by 6, right? So just write our equation. This equation is 2 plus 5 cos 6x, right? And x 30 is just pi by 6. So cos pi is negative 1. So negative 5 plus 2. So I am at my lowest point at 30 degrees. So I am going to have 0 at 15 and 0 here. So my graph looks something like this. And I need to draw it until 120. So I just need to repeat this part. All right, so something like this is how my graph is going to look like. So what question was this? Question 15. All right. Something like this. Yeah, pretty much. So I hope that made sense. So you can draw the graph of cos x and then do the translation, or you can use the information. I know my principal axes. I know I can plug in some values, right? I can plug in some values because I have cos 6x. So what values I can put in? I can put in pi by 6, 2 pi by 6, 3 pi by 6. And pi by 6 is just 30 degrees. 2 pi by 6 is 60 degrees. 3 pi by 6 is 90 degrees. So I can plug these values in quite easily, right? So if I have 6 times x, I want to look at plug in pi by 6 2 pi by 6, 3 pi by 6. These are easy values. If I have 3x, what x values I need to want to plug in? Pi by 3, 2 pi by 3, 3 pi by 3. These will give me easier values, right? So that is one good trick to know. And yeah, you can just plug in some values and you are going to see that your graph looks something like this. And that is the solution to question 15, and everything else we're going to do in the next video. I hope this was helpful.